I would like to take you to a successful project about edge computing and sustainable agriculture in Germany in the pilot region of Rheinland-Palatinate. My name is Daniel Eberz-Eder, and my outline for today's presentation is an introduction, the location of the use case, concept in agriculture, then an innovation as the key to success, origin of important data in digital agriculture, IT architecture of the gearbox infrastructure, resilience in digital agriculture, resilient edge computing, IoT use case, and a conclusion. Empty grocery shelves are not a reality in our country, are they? What happens when central internet and power-dependent processes no longer function? Our world and the processes stand really still. After a talk in 2018, where I talked about the need for resilience of digital infrastructure and crisis, I received the answer that we won't have anything like that. No, you can see it in your daily life. COVID-19 changes the whole world and their processes. Climate change influences millions of people and many sectors. And finally, the Ukraine war. The same, changes everything. Now, where do I even come from? Germany is located in Europe and is the most populous country in the European Union. My home is Rheinland-Palatinate in Germany. You see it there. And what we are doing, we want to build a digital infrastructure with applications that are accessible to all farmers. From a geographical perspective, Rheinland-Palatinate is very diverse. This then has an impact on the agricultural production. Here you can see an overview of the agricultural crops. You see on the left side from crop production over meadow, livestock, viticulture, vegetables and fruits, and beekeeping. All these kind of production, agricultural production, are in Rheinland-Palatinate. This diversity in production also has an impact on digitization. This is because the production areas are digitized to different levels. Our goal is to establish an infrastructure for the secure and resilient use of public operationally data, testing new processes and technologies, to get a good practice transfer into the sector for using these applications, and to design an innovative framework. What we are doing is we want to establish an impact-based consulting 24/7 with our applications, our digital application like the Gearbox Messenger and chatbots and so on, our edge computing. Establish an international, we are using established international standards. We don't want to create new standards and so on. And our aim is to integrate innovation and digitization projects into existing developments. On the one hand, we have a classic sector like agriculture, and then the tech sector. Agriculture has historically always been a driver of innovation. So we also want to generate innovations here through projects such as resilient smart farming. We need a renewal of the status quo of technologies. We need urgent development of understanding that digitization is a transformation process and not a hype or a buzzword. We know that successful companies form new organization forms on a project basis, that we can come in our public service center, and agile and dynamic work requires a change in thinking on the part of the players. That's really important that we can do that. For our strategy, open source technologies are the key to success. That's very important here in our summit, that we are using open source technologies in order to have success in our digital infrastructure. Nevertheless, the best innovation is nothing without simultaneously concentration of competences. The theory of innovation by Schumpeter said, eternal change through creative destruction. That is what we want to do now. And where does the important data in agricultural production comes from? We see geodata, then they have important public and operational information on soils, or weather data, current weather status and forecasts are essential for farmers. GPS can improve farm measurements, like precision farming, satellites, images, like the Sentinel data, or IoT sensor data improve local information, drone important information through the growing season, or information on the presence of deer before moving. Robotic opens the possibility for autonomous processes in agriculture, and management, that is very important for farmers, is one of the most important part in smart farming because of the bureaucracy. Maintaining resilience of food stocks and supply chains is a growing concern. Digital systems, use of regional sensor data in smart farming improves knowledge base for decision making. IoT and local data use will increase in the next years. But the moment of crisis, agriculture is a fundamental element of the critical infrastructure. Therefore, we say that decentralized data storage through the offline first principle is that what we want to have for the future. Open source technology is the key for that. How is the IT architecture to achieve the above goals now? First, do we have proprietary applications from the country that require a central data infrastructure? You see that on the right side. Behind them are private clouds or public clouds. Servers, through these services, the following applications can be served: GeoBox Messenger, GeoBox Viewer, and agricultural meteorology data, weather data for farmers, and that on S3 Geodata management. And what we want to do is we want to create a multi-cloud management for central and decentral data storages. And that with a cloud out strategy, a hyperscaler strategy, and then this hybrid multi-cloud management of data in agriculture. And the second one is we have an important level of communication with the various networks like 5G, or that's very important in agriculture IoT with LoRa, long-range wide area network. These can be organized in two ways: public in this way, or private networks. The third step is now the most impressive and the innovative one, the way to the edge. We call the third level resilient edge computing. And you see there the HofBox, and I will go further. I will show you these developments later on. And a regional server for resilient edge computing. And you have there also many applications because it's containerized. Our infrastructure looks like that. We will have a short focus on the central application because they shown us the importance of having application for farmers to produce sustainable and smart. So the first one is the knowledge boxes. What are knowledge boxes in the central data storage? That means information from the advisors, from public or private advisors about soil, soil types, cultural techniques, sustainability measurements, and so on. And the we have a geobasis data from the country, real estate, cadastral, soil maps, location indices, climate scenarios, and so on. And the third part, the most impressive part, is time-sensitive data. That means weather data, data about diseases and pests, and also of the phenology. All these we have in this colorful map. From my home region, you can read the site-specific soil moisture. The legend shows you 4 different humidities: very dry, dry, wet, very wet. And what is important about that, it helps to thrive on the right moment on the soil and reducing soil compaction. Or it's important for sowing crops. You have information about the soil moisture, and we have there a classification on it. And it is site-specific for all your fields. You can see and compare actual data, like this data, actual data, with historical data. Down, you see the slide 2018 to now, and can maybe changing strategy of production. The next one is this screenshot of the browser application. We see a calculation for the local on the probability of infection of important crops. To make this information easy to understand, it is visualized according to the traffic light model. You see that in yellow, green, and red. Why this is important? It's important for the farmer's decision about the best time for pest control. Now we come to the heart of development and today's presentation, our innovation in IT infrastructure for resilient smart farming is resilient edge computing. What does it mean? Why are we dealing with this topic? I show you for a few minutes slides about the current crisis in the world. That is one reason for our goal, so that agricultural sector is more resilient in the near future. Especially in actually secure infrastructure, the effect of an event is high. That also says the vulnerability paradox, that the effect of an event is very high. What we have is a holistic approach to resilience in agriculture. The importance, you will see that on one hand, we need a resilience of digital infrastructure by cybersecurity on emergency communications, but also on an economic point of view. Resilience is very important, and that means climate change, environmental problems, structural change in agriculture and rural areas. It's the main topic in Europe, and what we are doing, or what we want, is digital applications and infrastructure can make a valuable contribution to solving the challenges. Excuse me. Importance of edge computing in agriculture. Why agriculture as use case? I hope you noticed from what I said earlier that agriculture is a good use case for edge computing because it's critical infrastructure. Here we have the need because of critical infrastructure. Agriculture depends much on centralized infrastructure and cloud computing. And resilient edge computer focuses on the resilience and reliability of agricultural production. At the operational level, this can be linked with public geographic information, like you see before, and private sector production data using GeoBox tools, GeoBox app. We will see that in a few minutes. What is our aim? Reduce risks and maximize the resilience. We want to go to the picture here, resilient edge computing and the HofBoxes. Where does it is in this graphic? I would like to give you an insight into our development on resilient edge computing there. You see there are three important parts. The edge gateways in this part, the edge gateways. Then you see regional server with open horizon that provides remote and autonomous management of containerized applications. And you see the edge devices, which called by us HofBox. And that is the way we want to go. And we will focus on this part now. And we will see on this overview, which was developed by Expeer, my partner here today, and IBM. You can see the downloaded application on your edge device. That is the overview. And you see here the now downloaded applications, which in the application manager, you have the possibility to you have applications containerized, and this container is now ready to start. You see the starting button in order to start the application. GeoBox app on your edge device. The next slide, if we now go a step further, on the left side to the App Store, we now see available applications which you can push. In this part, it is you can download these applications on your edge device. Here, that's open source software like LibreOffice as a free and powerful office suite, and Streamsheets for Management Center for Eclipse Mosquito, MQTT example for IoT. So, how it looks like, how it looks one application from the GeoBox. This is a dashboard, and first we have a profile with basic information, who I am. Secondly, the farm profile. Secondly, we have a messenger service integrate in our application, and then a map service. The farmer can see their fields of production, and then we have a special topic, integration of Watson Assistant as chatbot for plant protection, and the table editor, and then an innovative data storage called Buchungsjournal, and you see the LoRa IoT sensors. What does it mean, innovative local event store? Our innovative local event store called Booking Journal has a link to internationally accepted standard vocabularies. That's very important, that we create not new vocabularies and standards. We are using the ontology from the W3 and the vocabularies from the Food and Agriculture Organization. And we are having there knowledge graph generation, and these Buchungsjournal, these innovative local event store, can be evaluated by any Sparkle queries, and explicit semantic data modeling for the realization of farm information systems. Behind the interface on the left side in our chatbot, you will see there the queries are performed automatically in our booking journal, in our innovative local event store. Okay. What does resilient edge computing and what is the HofBox? I'm happy to show you today in live our prototype of HofBox here in the front. And thereby we can realize edge device as decentralized data storage and managed over Open Horizon, the IBM Edge Application Manager. Why we want to accelerate data access when the internet connection is the bottleneck, data protection and data sovereignty as operational data is stored on site, functionality in the event of disruptions to the internet connection. That is very important for farmers because they are critical infrastructure. You see that. You see a distributed denial of service on the infrastructure, on a centralized infrastructure, and that is what we want to have. Resilient edge computing, if that happens, you have your own decentralized data storage and you can process and produce. These are our two prototypes. The version left on the side consisting of a Raspberry Pi. You see it here, it's a normal one, Raspberry Pi 4 with LoRa expansion board on it for the IoT use case. And then the x86 hardware with components tuned to Open Horizon. That means simply it's more powerful as a Raspberry Pi. So, resilient edge computing with LoRa network in agriculture. You see there on the left side the IBM Edge Application Manager, the Management Hub, and the Open Horizon agent. And you see there our GeoBox application. I show you that before, our GeoBox application. And you see now the LoRa gateway. It's very important that you have a LoRa gateway on it, and down the LoRa sensors and LoRa nodes. And you see the secure container registry. Jean, you have tell us that before, and that's a very innovative model in agriculture that we can do that in this way and realize edge computing, resilient edge computing in this way. And on the right side, you can see the connection to different LoRa nodes. And you want to have a deeper look on that. What does it mean? What does it mean? LoRa nodes, you see there LoRaWAN sensor data from soil moisture and in the GeoBox application. And how it looks like, soil moisture. That is what I do in many times. Soil moisture monitoring is very important in agriculture. We have different depths in which we have to monitor the soil moisture, and we have different soil structure. It's important for farmers because it depends on the soil moisture. And then the next one is the open data form. That is what we want to do is all this data in agriculture we will show people in our virtual farm called Open Data Farm. You can see that on opendatafarm.com. You can have a look, and you see that we have so many data in agriculture which we want to collect now and have a first decentralized data storage and then go in the multi-cloud component level. And yeah, all these data in agriculture are very important for farmers. One example, the integration of the Watson chatbot. You see it on this topic. You see we have a scenario of a resistance manager for crop protection integrated in our GeoBox application. It is a special feature because we are using there the international ontologies from the FAO, enabling semantic search on it, automated query is possible, and you see that that we can assist with a chatbot on it. So, I come to the conclusion. At the beginning, I told you about the different crises of the time, and we are knowing now that crisis events have a significant impact on digital infrastructures and especially agriculture. We can show that there are technological solutions of edge computing, and Open Horizon is readable as a solution in our use case. In our opinion, and according to our experience, open source is the key to success. We are convinced that in critical infrastructures, our offline first concept will become standard in the future. Use of digital applications in agriculture can be a significant contribution to sustainable agriculture. I hope you can understand that now. Minimize risks, maximize opportunities and benefits through smart farming for sustainable agriculture. You can join our developments and teams on different ways. One over our Resilient Smart Farming Lab on the left side. You can go on the side, and we have many publications, academic publications, and a video on it. And the second possibility is to join the LFH group, where we work now also with our use case since 2018, 19. And we are happy if you join and bring us together there. There's also our video about resilient edge computing. We have a short video in order to demonstrate the decentralized ecosystem in combination with regional infrastructure. And thank you for your attention. Any questions?
Daniel, I'm very interested in how the data sharing, the farmer is sharing data back to the regional. How's that work?
That's very interesting. It's very complicated in agricultural sector because all things are closed, a closed job, and at the moment it's we want to have a community to share especially IoT sensor data. At the moment it's about the TTN, the Things Network, about this point, but I guess there are many other options in the future we want to do. Yeah. Who wants the data? When farmers share their data, that are only data like weather data, soil moisture, and so on. No critical data about companies and their business. They will not share that anytime. No farmers wants to share their business and their business plans. That's normal.
Installation of your HofBox and your other equipment is being done by the farmers instead of the application? So how much is done by you or your personnel?
At the moment, it's on the starting point. The prototype is now finished, and we are done with that, and that's the next step in next year, I guess, 2023. Is the point where we want to go out to the farmers and want to bring there the HofBoxes.
Well, the SPO.
Yeah.
You send it in a box to the farmer. He just plugs it in.
Yeah.
And it turns on and configures itself.
Yeah, that's it. With a secure onboarding process. Yeah.
What would you estimate the kit costs are going to be to a farmer, and how many would you need per acre or some to measure to effectively provide for the measurements he's going to do?
That's a good question. It is. I show you that before that we have in Rheinland-Palatinate a very different kind of farmers. We have many small really small farmers and medium farmers, and few big farmers. that is very difficult. It depends on the cost of a HofBox. That is the only thing they want to ask. What does it cost if I want to get a HofBox? And if we have different hardware, I think low-cost hardware or the medium-sized hardware like the x86 and the regional server, okay, that's where Open Horizon runs. That's a server, but I guess the mini server have a good possibility to go into the sector. Any questions?
What about data storage? How much data storage does this unit need? How does it go?
Yeah, it depends a little bit on your use case. If you want only your farm data, your own farm data, nothing more. It depends also on how many fields you have, and therefore you have not so much. Maybe 30 GB, that's enough, yeah. But it depends what applications you run on your device. Yeah.
Can you say a few words about that AI at the edge? So you've got a camera looking at what's going on, too much data for the cloud, but on the other hand, you need the AI at the edge.
That's a perfect direction. We run on that topic because it's very interesting and very important that we have on the edge also AI possibilities, because of you can show maybe cows in your farm, and you have maybe a camera on it and can see the health of the cows or sheep or so on. That's very interesting. At the moment, we are happy that we have a HofBox as a decentralized data storage with the possibility for chatbots or LoRa data, but that is the next step that we want to bring to the edge, the AI. Yeah, that is what I said with competencies. We have to go further. We are running on technology, but we have to bring it in the sector, in all sectors, all kinds of sectors. And that is very important in agriculture, that we train the farmers in using data and the right data. Okay. No questions? Thank you.